everyone, this is K Devender Reddy, Assistant Professor in Department of Electrical Engineering. In this video, we are going to discuss about parallel operation of alternators, how we will synchronize the alternators with the busbar, and what are the conditions and what are the advantages of the synchronization or a parallel operation of the alternator. So let us look into the actual definition of the synchronization. So the synchronization is nothing but it is a process of switching an alternator to the another alternator or with a common busbar without any interruption in a supply is called as synchronization. The synchronization is simply defined as it is a process of connecting the alternator with the existing busbar or existing alternator system without any interruption in the power system. Power is called as synchronization. There are certain conditions for connecting the alternators in parallel or in parallel with busbar. There are certain conditions to connect the alternator in parallel with the another alternators which are already running and which are already connected to the busbar, or we wanted to connect one alternator to the busbar system. There are certain conditions. The first condition, the terminal voltage of incoming machine must be same as that of busbar voltage. Whatever the alternator you are choosing for connecting that alternator into in parallel with the busbar or in parallel with any other alternator which are already running with the system, the terminal voltage must be same. Next one, the frequency of the generated voltage of incoming machine. The frequency of the generated voltage of incoming machine must be same as that of busbar voltage, busbar frequency. And third one, the phase sequence of incoming machine must be same as your busbar. These are the three conditions which must satisfy any of the alternator which are going to be connected in parallel with the busbar system or in parallel with any of the alternator which are already running in the system. They must maintain the incoming alternator you are choosing to connect. It must be same voltage rating as a busbar. The output voltage of the alternator must be same as the generated voltage of the alternator with the busbar. And the frequency of the voltage which is generated of incoming alternator must be equal to busbar, as well as the phase sequence also be equal with the busbar system. There are certain advantages for parallel connection. So when you are connecting the alternators in parallel, we have certain advantages. That is, continuity of supply is possible. So when any of the alternator may be damaged or maybe comes under the shutdown because of the annual maintenance and all these things, the interruption of the power supply will not take into the picture, and the other alternators which are already connected in parallel, they can take the extra load which is carried out by the shutdown alternator. Repairs and maintenance, the individual machine can be carried out one after the other without affecting the normal routine work. Depending upon the load requirements, any number of alternators can be operated and the remaining can be put off. For example, if the load on the busbar system is less, you can switch off the alternators which are connected in parallel to the busbar system. If the load on the system on the busbar increases, then you can switch on the alternators which are connected in parallel to the busbar system. So according to the load requirements, we can run the alternators. So not at the time, not all the alternators are running at a time irrespective of the load. It is depending upon the load, we can switch on or we can switch off the alternators. That is depending upon load conditions without affecting the supply. And it is economical, and it also improves the efficiency of generating stations. And new alternator can be connected in parallel when the demand increases, and this will reduces the capital cost of the system as we discussed. So the main intention in a parallel operation to increase the efficiency of these power generating stations as well as the continuity of the supply is possible without any interruptions because of any of a technical reason. One of the alternator may get switched off, so the other alternators which are connected in parallel, they can take over the load. And the annual maintenance and repairs and maintenance will be routine work will be going on if the alternators are connected in parallel. Then we can one after another we can switch off, and we can the routine whatever the annual maintenance work will be going on. And depending upon a load requirements, we can switch on or switch off the alternators which are connected in a parallel to the common bus bar system. So any of if the load increases, you can increase the more number of alternators, or if your load will be less, you can also switch off the alternators which are connected in parallel to the common bus bar system. So depending upon the load depend upon your season as well, and load depend upon your weather conditions as well. So generally in monsoon season we have more idle power than steam, so at the time we'll offer more load on the hydel stations, and we can reduce the power generation by the thermal stations, and the routine maintenance work will be going on in that particular period. So depending upon the requirements, we can supply the power to the consumer without any interruption. That is the main advantage of the parallel operation. So there are some methods for synchronizing the alternator. The term we already defined. The synchronization is a process without any interrupting the power supply to the consumer. We can connect the new alternator to the existing system or existing bus bar. That is a process called as synchronization. The operation is called as parallel operation. There are not only these three methods, we have other methods as well, but generally we are going with a dark lamp method, bright lamp method, synchroscope method, two bright one dark method. Like we have 3 to 4 type of the methods for synchronization of the alternators, but more generally specifically these three methods are very very important. Dark lamp method, and very basically we used a bright lamp method as well as the synchroscope method for synchronizing the alternators in parallel to the existing bus bar system or existing alternator. Let us here I'm clearly in this figure I'm clearly showing the one alternator, that is existing alternator, which is already connected to the bus bar. So they are three-phase bus bar system, RYB phase sequence. It is connected to the one of the alternator which is already running. This main switch already closed. It is an existing alternator, right? So I'm using a dark lamp method for synchronizing the new alternator, that is alternator number 2, in parallel with the existing alternator 1, or in parallel with the bus bar system. So before synchronizing the new alternator, before connecting the new alternator directly into the bus bar, we have to run the alternator with a rated speed. The alternator anyway it is connected to the prime mover, so whether it is a steam or hydel or a diesel, whatever, and I'm not going into that particular type of the prime mover which is connected, and type of the input fuel for the prime mover. But any of the alternator which is connected to the different, whatever the kind of prime mover it is connected to the alternator. First of all, bring the speed of the alternator into the rated speed. Let us we call it as a synchronous speed of the alternator. And once it reaches the synchronous speed, first of all, check the voltage, line voltage of alternator with the help of a voltmeter. With the help of a voltmeter, check the terminal voltage of the alternator, whether it is equal to the bus bar or not. You have to check the bus bar voltage as well as the alternator terminal voltage, that is called a line voltage, between any of the phases. First condition you have to check, condition 1, check voltage. The voltage level or the magnitude of voltage of the bus bar as well as the your incoming alternator output line voltage. Once it is satisfied, then going a phase sequence as well as the three conditions. What are the three conditions we have? One is the phase sequence, frequency, as well as the output voltage, that is the rated output voltage. So first of all, check your voltage levels of the incoming alternator with the bus bar with the help of simple voltmeter. Then after, check phase sequence. After that, you have to check the frequency of the incoming alternator, whether it is equal to the frequency of the bus bar or not. So anyway, we know the speed ns is equal to 120 f by p, right? From this, p is equal to frequency is equal to nsp by 120. So from this formula we can measure, we can find out the frequency of the incoming alternator, or with the help of the frequency meter also we can check whether the incoming alternator frequency is equal to the bus bar frequency or not. That we can also check, or with the help of this formula also you can find out the frequency of the alternator, whether it is equal to the bus bar or not. So after these two, check the lamps which are connected across the each of the line. So lamp 1, the one terminal is connected to the bus bar R terminal. The second terminal is connected to the alternator R terminal. Lamp 2 connected to the bus bar Y terminal, that is yellow. And also lamp 2 is connected to the other terminal is yellow terminal, that is Y phase of the alternator. Similarly, uh, lamp 3 is connected B phase of the bus bar as well as the B phase of the incoming alternator. So the lamps are connected across the lines of the bus bar as well as the your incoming alternator. So when it is reaches to the synchronous speed, or when the alternator reaches to the rated speed, you have to check the voltage level. Then after you can also calculate frequency. Then observe the lamps which are connected across the switch. Let it be this TPST switch, triple pole single through switch, TPST switch, triple pole single through switch. Across the switch we connected 3 alternators. Our intention is to synchronize the alternator 2 with the busbar system or existing system with the help of a dark lamp method. So if the phase sequence of your incoming alternator is equal to the phase sequence of the bus bar, these 3 lamps will flicker at a time. These 3 lamps are glowing on and darken. These 3 lamps are at a time. These 3 lamps are glowing uniformly together and becoming dark together if phase sequence is correct. If phase sequence is correct, 3 lamps are glowing at a time and becoming darkened at a time. If the phase sequence is not right, then 3 lamps are alternatively glowing and becoming darkened. These 3 lamps are alternatively glowing on bright end as well as they becoming dark if the phase sequence is wrong. So you have to check with the help of the lamps also whether the phase sequence of the incoming alternator is same as the phase sequence of the bus bar or not. So you have to check it and you can correct it, and all the 3 lamps must be glowing uniformly together and becoming dark uniformly together. Then only the phase sequence of the incoming alternator is same as the existing bus bar system. So once the phase sequence is right, once the phase sequence is correct with the bus bar system, then you have to observe the flickering of the lamps. The lamps are flickering, that is on and off, that means glowing bright and glowing uniformly together as well as they becoming darkened together. That is the rate of glowing as well as the darkening, we can call it as a flickering. So we have to, next step, we have to minimize the lamp flickering by adjusting the speed of the alternator 2. So minimize the flickering rate of the lamps by adjusting the speed of the alternator 2, right? So then after, once it is minimized, the lamp flickering rate is minimized, then observe middle of the dark period. Then in the middle of the dark period, you have to close triple pole single throw switch, that is TPST. You have to sense the middle of the dark period by minimizing the lamp flickering rate, by increasing or by adjusting the speed of the alternator 2, and then sense the middle of the dark period and close the switch. So that is the case, the alternator 2 is connected to the bus bar, but it is under floating condition. It cannot supply the power and it cannot receive the power from the bus bar system. It is not like a generator. It is not like a generator, and it not like acts like a motor. It is under the floating condition. In that floating condition, we have to push the alternator into the generating mode or push the machine into the generating mode by increasing the excitation of the alternator 2, and the output voltage of the alternator 2 slightly greater than the busbar voltage. Once you have increasing the excitation and the output voltage of the alternator to slightly greater than the bus bar voltage, then the alternator or incoming machine now acts like a generator, and it is now supply the power, and it is take the load from the bus bar system. It is now supplying the energy to the bus bar. So there are certain demerits for this kind of dark lamp method. So it is not possible to judge whether the incoming alternator is slow or fast. With the help of the lamps, we cannot judge it. And the lamp can be darkened even though a small value of voltage may present across the terminals. So it is a little bit difficult to sense the middle of the dark period. That is the main disadvantage of the three dark lamp method for synchronizing the alternators with the bus bar system. So this is all about the dark lamp method. And similarly, the quite similar kind of method called bright lamp method for connecting the alternator in parallel with, or synchronizing the alternator in parallel with the existing alternators or bus bar. So anyway, alternator 1 is already in parallel, or it is already connected to the bus bar, and I am going to connect alternator 2. I am going to connect alternator 2 in parallel with the bus bar system. The similar way, the first condition, you have to check voltage. The first condition is you have to check the voltage with the help of a voltmeter. So first of all, you have to bring the speed of the incoming alternator into the rated speed. So once it attains the rated speed, you have to excite the alternator field winding with the auxiliary supply, whatever we have. So once the excitation is connected to the alternator, excitation is given to the alternator field winding, then check your output voltage of the alternator whether it is equal to the bus bar or not. Or if not equal, then you can adjust the excitation and make it as equal to the bus bar voltage. That is a condition 1. The second condition, you have to check the frequency F equal to NSP by 120. Frequency of the incoming alternator output voltage must be equal to the frequency of the bus bar. That is also you have to calculate, or with the help of the frequency meter, you can check whether the frequency of both the systems are equal or not. Then this will be done. After that, third one is the phase sequence. Third one is the phase sequence of the incoming alternator, whether it is equal or not, that you have to check with the help of the lamps. So the three lamps are cross connected here because of the bright lamp method we are choosing. So the lamp one of the terminal is connected to the R phase of the bus bar, and the other terminal is connected to the yellow terminal, that is Y phase of the alternator. Similarly, alternator 2 is connected to the yellow of the bus bar, and lamp 2 is connected to the B phase of the incoming alternator, and lamp 3 is connected across B phase of bus bar and the Y phase of the alternator. This is called as a cross connection of the lamps, and with the help of this cross connection, we can sense the middle of the bright period. And when the middle of the bright period, when we have to sense the middle of the bright period, in that middle of the bright period, we have to close the TPST switch to synchronize the incoming alternator into the bus bar system. So that is why, first of all, you have to check the voltage level, then after check the frequency, then after you can observe the lamps. Lamps will glow the brightest when two voltages are in phase. That is, the brightness of the lamps are very sensitive with the voltage, that is, it is square proportional to the voltage, and then V1 must be equal to V2. If phase sequence is same, the lamps will start flickering uniformly. You have to decrease the flickering rate of the lamps by adjusting the speed of the incoming alternator, which is going to be connected in parallel with the bus bar system. So you have to, if the phase sequence is same, all the lamps will start flickering uniformly. If not, the phase sequence is it is not right, then the lamps will not flickering uniformly. They will flickering alternatively, one after another. So you have to check whether the phase sequence is right or wrong. Once you have to identify whether it is right or wrong, then you can correct it. Then all the lamps should be flickering uniformly. And then after, you have to minimize the flickering rate by adjusting the excitation of the incoming, adjusting the speed of the incoming alternator. Then after, you have to close the switch by sensing the middle of the bright period of lamps. That is the case the bright lamp method for synchronizing the alternators in parallel with the busbar system, which is quite advantageous than the previous case, whether the middle of the bright period we can easily sense because the brightness of the lamps is square proportional to the voltage. Brightness is proportional to the square of the terminal voltage or line voltage of the alternator. So if there is any minute changes or minute difference of the voltage will also reflect in the brightness of the lamp. That is why it is more advantageous than previous case. And the one more method we have, the Syncroscope. The more accurately we can sense whether the incoming alternator is little bit fast or slow. That will be sensed by the Syncroscope device. So the Syncroscope, the system is same, and the circuit diagram and how we will process the step 1 and step 2, everything is same, right? Then a Syncroscope, the stator of the Syncroscope is connected. See here, the Syncroscope rotor is connected to the incoming alternator and the stator is connected to the existing alternator. The pointer attached to the rotor, the pointer is attached to the rotor. The pointer will indicate the correct time of closing the switch, that is at 12 o'clock position, right? So if anti-clockwise rotation, if the pointer will rotate anti-clockwise direction, that we'll see here. If the pointer will rotate in anti-clockwise direction, that represents the slow, that is incoming alternator speed is slow with the existing alternator. If the Syncroscope pointer will move in a clockwise direction, that represents the alternator 2 will be faster. The speed of the alternator 2 will be more than the alternator 1 or the system which is already connected to the bus bar. So we have to adjust the speed of the incoming alternator and make the pointer will be at a 12 o'clock position. So when the pointer will be at a 12 o'clock position, you can switch on the TPST switch which is connected to the incoming alternator. Then the alternator is connected to the bus bar system. And anyway, we know already about the floating condition of the alternator. So we have to, once close the switch, we have to increase the excitation for the alternator 2, slightly increase the alternator excitation to push into a synchronism, and it will start supplying the power to the bus bar system. And this is about the three methods how we will synchronize the alternators with the bus bar or with the existing alternators. So in that process, in the process of synchronization, we must know the synchronizing current, synchronizing torque, as well as the synchronizing power. If the two alternators are having, it may be of equal voltage, the magnitude of voltage of the, for example, two alternators are going to be connected in parallel. One alternator already connected in parallel to the bus bar system, the alternator 2 which is going to be connected in parallel to the bus bar system. In that case, whether the phase, whether the magnitude of the voltage are equal or not, and they must be in phase opposition. So for example, here I am showing in a vector diagram. This is the actual reference position of the induced EMF of alternator 2 E2. If they are perfectly synchronized, E1 must be E1 as well as the E2 must be equal in magnitude and phase opposition. E1 and E2, both the magnitude of induced EMF of two alternators must be same and they must be in phase opposition. Due to any of the disturbance, whether the load on one of the alternator may increase, or a speed of the one of the alternator may increase, or excitation may increase, but any of the reason, the induced EMF of the alternator will be of equal to the induced EMF of alternator 1, but it will be of not exact phase opposition. It is falls back by an angle called del, which we can call as a load angle, which will be called a load angle. If two alternators are exactly the same, means exactly the perfectly synchronized, there is no resultant induced EMF into the picture. Due to any of the reason, due to any of the disturbance, this may be coming to the picture, the load angle del. There will be a resultant induced EMF between the local circuits of the alternators 1 and 2 which are connected in parallel. A resultant induced EMF will come into the picture which is across the local circuit, Due to this resultant induced EMF, a current will be flowing in the local circuit. That current is called as synchronizing current. A synchronizing current will be circulating in the local circuit, that is in the armature of alternator 1 and armature of the alternator 2. In the local circuit, the two alternators are get connected in parallel through their armatures. So a ISY, the synchronizing current, starts flowing in the local circuit. So the resultant induced EMF is equal to 2E cos 180 minus del by 2. So E is the magnitude of induced EMF and cos of 180 minus del, that is a load angle, divided by 2. And this synchronizing current is almost in phase with E1. In this vector diagram I am showing, the synchronizing current is almost in phase with E1. In this case, the synchronizing current is a generating current, or it will be of a generating action for E1. The synchronizing current will be almost in phase with E1, means it is a generating current for E1 and motoring current for generator 2, that is machine number 2, which is connected. The ISY will be acts like a generating current for alternator 1, and it is a motoring current for alternator or machine number 2, which is connected. So this synchronizing current will develop the synchronizing torque, that is called as a TSY, synchronizing torque, which will come into the picture. The synchronizing torque will come into the picture. For example, if the disturbance of alternator 2 will be of speed of the alternator 2 may increases. For example, the disturbance may be of the speed of the alternator 2 increase. The synchronizing torque will de-accelerate alternator number 2 as well as the accelerate alternator number 1 to settle down the synchronism, or to pulled into the synchronism without any disturbance. That is the case if the two alternators are get connected in parallel. Due to any of the disturbance in any of the alternator, the synchronizing current and synchronizing torque will come into play, and which restore the synchronism. See here, 2 is sine delta by 2, del by 2 if del is very very small, and the synchronizing current we know that is equal to ER by ZS, impedance of the synchronous impedance of the alternator. The resultant induced EMF equal to E del, that is E del by ZS. That is, if the resistance of the alternator armature winding is very less compared to the inductive reactance, or that is the synchronous reactance of the alternator, you can also neglect it, and it is E del by XS. So we already discussed about synchronizing power. It is defined as the difference between input power to alternator at a power angle del and another alternator which is of operating at a power angle del plus another new angle called a del dash, right? So P1 is the power of alternator 1, that is E1 ISY cos phi 1, and P2 is E2 ISY cos phi 2. The synchronizing power is nothing but the alternator 1 P1 equal to P2 plus copper losses. The previous vector diagram we represented synchronizing current is the generating current for alternator 1 and motoring current for machine number 2. So synchronizing power is equal to E1 ISY cos phi 1, that is equal to P1 E1 into ISY when phi is very very small. E1 into synchronizing current already we know that is E del by XS. So E1 into E1 E square, that is E1 square del by XS. So total synchronizing power, this is per phase quantity. This is per phase quantity. So for 3 phases, 3 times of the E1 square del by XS. This is actually the voltage vectors for the alternators which are connected in parallel. In the external circuit, both the alternators are co-phasors. But in a local circuit, that is between alternator 1 and 2, they must be in phase opposition. And we already discussed about a synchronizing torque. The torque that acts on the shaft of the synchronous machine when the rotational speed of the rotation or speed of the rotor deviates from the synchronism or a synchronous speed, and keeps the machine into synchronism by offering the retardation torque to the one of the alternator which are going to be out of the synchronism, and accelerating torque for another alternator. And the synchronizing torque TSY equal to 3 times of PSY into 60 by 2 pi ns. This is the magnitude of synchronizing torque will develop when any of the alternator will deviate from the synchronism. So this is all about the parallel operation of the alternators, how we will synchronize the alternators in parallel, or we will synchronize the alternator with the bus bar system. And we discussed the three methods: dark lamp method, bright lamp method, as well as the synchroscopic method. And we analyzed how the synchronizing torque, current and power will come into the picture, and how it will restore the synchronism if any of the disturbance will come into the picture in the synchronized alternators. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.